So welcome. In this particular session, I will be talking about deleting an element from the linked list. In the previous session, we have talked about deleting an element from the beginning and from the end, right? So here we will see how to delete an element. It is anywhere in this linked list. It may be at the beginning, it may be in the middle or somewhere else, or it may be at the end, or the element may not be there in the linked list. So I have considered one function which is the delete element. Okay, and I have mentioned this the option as 7, sorry, option is 8. Okay, and this is where I guess. Okay, and this is my the delete element, function itself. So here you can see I put on one list. Okay, now suppose if the list is null, then what will happen? You cannot delete the element, right? Then if this is not null, then you have to check whether the number is there in the list. Suppose we want to delete 50. Suppose we want to delete 50. So you will first check here 12, no, 34, no, okay, 50, yes. So after that, we're going to delete this element, right? Now, if the element is not deleted, if the element is not there, suppose a 75, we're going to check out and we'll reach to null, right? And we'll come to say, okay, element is not there, element is not found, we cannot delete it. Now, if it is the first element, 12, that means start is pointing to 12. So if I remove 12, my start pointer should point to 34. Okay. So let me tell you again. Okay. Say for example, if I want to delete an element, I have to check whether the linked list is first, it is empty or not. If the linked list is empty, that means start equal to null, start equal to start equal to null, right? So if start equal to null, yes, that means the linked list is empty, right? I will write here printf the linked list is empty. Correct? Yes. Okay. Else, what I have to do? I have to traverse. Okay. So I take a pointer ptr equal to str. Okay. Yes. Now for before that, I have to ask the user, please provide me the number that I want to delete. Yes. So enter the element to be deleted. Okay. Slash n. Then scanf scanf. Okay. Percentage d and percent num. Right. So now I declare one int num and I declare one pointer struct node star ptr. Okay, right? Yes, ptr. Now what I have to do? I have to go on searching, right? Whether ptr reaches to null or we get the element. So how will I going to write it? While ptr not equal to null and an operation ptr not equal to ptr what? Ptr info, sorry, ptr info not equal to num. Okay, ptr equal to ptr. Next, let me explain it. So now ptr is here. Okay, suppose I want to find the 50. So ptr is not equal to null. Ptr is not equal to null. That is true. This is true. Ptr is also not equal to 50. True. So ptr equal to ptr next. So it comes to 34. It is also not null, not equal to 50. Both are true. So it will again come to ptr equal. Now we see ptr equal to null, not null. Yes, this is true, but it is not equal to 50. It is equal to 50. So that means this is false. True, false, false. So now ptr is equal to, we have this is 50. We found the element. Okay, now we'll see the step. Now suppose if we are finding 75, then what will happen? Till here it will go. Then we'll find ptr equal to null. This will become false. Okay, this is true. Then again it will be coming out of the loop. Okay, now I have to check here. Okay, if ptr equal to strt start. Okay, then I will write printf the deleted element is percentage d, okay, num, yes, and what will have start equal to start next. So it will move to the next, right? So I have deleted 12, so it will move to the next, okay, right? Else, okay. Now we have what? PTR pointing to 50. Yes, PTR pointing to 50. So that means now 34 must point to 50. Now, is there anywhere where I any pointer which having pointing to 34? No, right? Because PTR is pointing to 50. Now I need to point 34 to 45 because this has been removed, right? Okay, so that means what I have to do, I have to take another pointer which I take it as nothing but brief that we have done, right? Okay, and I will mention here brief equal to PTR, okay, and PTR equal to PTR next. PTR equal to PTR next, right? Now previous pointing to 34. Suppose we are deleting 50, right? So we write brief of next equal to PTR next. Yes, okay, equal to PTR next. Okay, equal to P, brief of next equal to PTR next. But the thing is, if PTR is equal to the last node, PTR is equal to the okay, PTR is equal to the last node, right? So brief is equal to PTR next. Okay, fine, that is going on correctly, right? Okay, yes, and free PTR. Okay, here also free PTR. Yes, okay, so everything is fine, perfect. So let me save, let me execute. So let me first create the linked list. Okay, number one, choice one, and insert number 12. Okay, 34. Then suppose a 50, 56. Okay, right now I want to delete an element, right? 8. The element that I want to delete is 50. Okay, yes. So, oh, I have not displayed it. Yes. So if you traverse, you will, okay. If I traverse, you will get the list. See, 50 has been deleted, right? Because I've not mentioned that. Okay. Now suppose again I delete an element okay 8. Okay, what I want to delete 12. The deleted element is 12. See, it is given, right? Now let me traverse 9. Yes, 34 and 56. Now let me delete the last element 8. It will also not be displayed. So 56. Right now I will traverse. Yes, so 56 is deleted. Okay. So what I have not done is that this particular statement I have not mentioned. So okay, I will mention here. Okay, and I will mention here. Sorry. Okay. Okay. So let me save it. Right. Let me revisit it. I hope you have understood. First, if the list is null, we cannot delete anything, right? Next, we have asked the user to enter the element to be deleted. He said suppose 50. So start PTR is equal to start, so it will point to 12. Okay, it will continue till it reaches 50, right? Now this condition will be false. So true and false will become false and it will come down. Okay. Now PTR is not equal to first element. So what will have? I mentioned, right, that previous element, previous equal to PTR. So previous will be equal to 34. So 34 next equal to 50 next. So it is 34 pointing to 45. Okay. Now suppose if I want to delete 12, right? So what will happen is PTR info, this will become true, so it will come out, right? Now PTR is equal to start, the element will be deleted, and now start will point it to nothing but the 34. Okay. Yes. So let me again execute. Yes. So if I put my choice says, for example, number 8, linked list is empty, right? Now again create the linked list 12, create the linked list 34, create the linked list 50, create the linked list 56. Okay. So now I want to delete an element 8. Let me say I want to delete 12. Deleted element is 12. Okay. Next, I want to try to delete. Okay. I want to delete 50. So delete element it is 50. Now I want to delete element is 56. Okay. Right. So my delete element is 56. So let me traverse. Okay. I have 34. So I want to delete the element and the element is supposed to 78. I have not mentioned that the element not found. Okay. So it is not going to the deleted element is 78. That is what it is, because I have not mentioned that. Okay. Right. So yes. So I hope you are clear with the entire concept. Okay. So right, if it is not found, right, that means what? Else if PTR equal to start, else I will just enter once here. Else if you know, else if PTR equal to null. Okay. If PTR equal to null, I will just write printf element not found. Okay. Element not found. Element not found. Else. Yes. Okay. So if PTR is equal to null, element not found. Okay. Let me save. Just I will check that only. Okay. So let me create a list. This 12. Let me create a list. It is 34. Okay. So let me display. So I have this. Okay. Now let me delete an element 8 and let us say it is 78. Okay. So it's given element not found. Okay. Yes. And then again, enter the choice that is coming. Okay. So let me tell you again. First and foremost, this loop has to be very clear. See, I will be going till whether PTR is equal to null or PTR I get the number. That is the reason why AND operation. Okay, any of them I get, okay, it will come out of the loop. And both are false, it will go and continue. So if I want to delete 50, the first PTR is not equal to null, correct? And PTR is not in PTR information is not also 50, so it will move on. So previous equal to PTR, PTR equal to PTR next. So we have come to 34, right? Yes. And then here in this particular, because it is not equal to start, it is not equal to null, so it will be deleted, right? So next, if I want 12, okay, so here only, okay, we got the number, we come out, PTR is equal to start, the element is deleted and the start becomes start next, so it will move to 34. Now you are not finding the element, so PTR will become null, PTR will become null, yes, and that is what, if PTR is equal to null, element not found. Okay, so this is very easy, right? So you have to check first whether the linked list is null, that is first. Okay, and then you ask the element to be insert, then you traverse. Okay, then you check whether it is the first element. If it is the first element, then start equal to start next. Next, you check if PTR is equal to null, means element is not found. Okay, and lastly, okay, that element is found. So since we are taking another pointer, prev of next is equal to nothing but the PTR next. So previous here and PTR is here. PTR next is 45, prev of next is 45. Okay, so thank you so much. I hope it is clear.